So it brings me a great pleasure to ask you once again to stand up and join me in welcoming to the stage Jonathan Altman.
Thank you very much. So we're going to talk about persistence with Devops, handling database schema updates and migrations, how we go about doing that. I'm going to try and be a little bit provocative. I want to try and get some thought going. I'm going to say some things. You may not agree with everything that it is that I have to say, but hopefully we can agree on kind of the big outlines of things, and it's great to have discussions on the details, and it's great to have different approaches at those details. But let's talk a little bit about DevOps in your database. We're going to talk about how to bring the DevOps process into your database change management process. We want to get the full benefits that DevOps brings with trying to make changes to our databases. And when we say databases, I really mostly mean in this case relational database stores. It's where the tools are the most mature. We want things like repeatability, auditability, and traceability. We want the configuration as code. We want cross-functional teams. And all of this will lead us to best practices for doing schema migrations, taking your database from its current state to the state that some future version of your application might need. So why am I doing this? Why am I giving this talk? So I'll give you the quick about me. I'm actually an engineer here at Capital One. I've been here for about 9 months. I'm part of the Tech Fellows group here. But because I've been here about 9 months, that's not really long enough to actually have a lot of deep experience of how do we do migration. So we're going to go down to the bottom thing, the 12 years that I spent building a travel booking system. Some of you, if you flew here for this conference, maybe you didn't, or if you travel on business, it's possible that you've actually used software I've written to book your trip. And hopefully when you did, and I didn't send you to the airport without a ticket. I have done that, by the way. I also filled up an airplane once with one passenger. Even when I went out on my own, as a single practitioner, when I started a new project for a client or some of the products that I tried to build on my own, I would still start every project with an empty database and a Git repo for my database migrations. It works both for big projects and for little ones. So let's talk about what it takes to bring schema migration into DevOps. So this is the George Clooney character from Up in the Air, and just like his character and his character's mother, I'm going to stereotype. It's faster, and that's important because I'm going to have a hard time fitting into my half-hour time slot. So historically, what does database schema migration look like between developers and DBAs? So those are the old dark days, right? The developers write the code. The DBA's job is to protect the database from the developers, right? Like keep them from screwing it up. And we as developers, and I started as a developer, not a DBA, but we kind of walk up to this big scary window and say, please, sir, may I have a column, right? And the DBA looks at that and says, well, I know you need some changes, but this is what you want, but here's what I think you need. And that may or may not have anything to do with what the application actually needs. So that's part of that. And then the question is, what kind of tools did those DBAs have? So these are the sorts of processes that a DBA historically, and I'm talking 20 years. I know things have improved, and like I said, I'm stereotyping, but a DBA might, or an operations person in production might open up a SQL console into however many database engines they have, and their job is to load up SQL scripts and hit go or run or do something like that for all of the migrations that need to be run across all of the systems and potentially all of the environments. So those changes may or may not have been checked into a version control system when the DBAs were responsible for it. Again, it was somebody's job to run it, and the question is, how do you keep track of all that, right? Like, are the DBAs, adding entries into a text file? How are they keeping track of all this stuff? So those can all be problems. The other thing you can run into is your DBAs may make ad hoc optimizations, let's say, in your production database. So I'm going to sort of separate that one out. That can be a good thing. Your production loads maybe change very dynamically. It may make sense, actually, to let your DBA say, well, I'm going to do some index optimizations or things like that that are only going to live in production that don't need to come back to development or QA or staging because they don't actually make sense in those environments, and they may be ephemeral. Like my transaction load may look like this today, it may change next week, I may drop or alter my indexes. So that's great, but when you have that sort of open the console, run a bunch of files, keep a log of what you did, you can run into some issues. You can run into divergence across environments. Hey, I forgot to run, the third out of 5 scripts in this one environment, and so now that database doesn't look like all my other environments. If I have a sharded database, so I have multiple identical shards, I might forget to run it on 1 or 2 or 3, or it died. And at the end of that, what happens is, your app layer will eventually break. You will eventually make one of these mistakes or have one of these problems happen, and now your application is incompatible with your database in some environment or some part of your partition system, and you are down somewhere. Now the next problem you have is auditing. How do I know? What state is this database in? How do I go back and look? How do I figure out what things I ran and didn't ran? How do I figure out what my breakage is? Then one of the big issues here is that second to last one, the incompatibility of goals between teams, right? We talked about, developers need to make changes to their application, and the DBAs are attempting to protect their database from it being broken. What we don't have, and this should sound familiar to people who are in on DevOps, is we're not at DevOps yet. We're not talking to each other. We're 2 separate groups, and we're not all thinking about the same problem. And then the other big problem with that especially is developers have all these great tools for code consistency, right? These DBAs have requirements for database consistency. Can we put those things together? Can we use some of our developer tools to improve that database migration experience so that developers can safely make their own changes to the database, and DBAs can be sure it's being done safely? By the way, that was supposed to be cats and dogs living together in harmony. I'll leave it up to you whether that's the developer or the DBA that's the cat. So what qualities do we want in the tools that we're going to use for this to get to developer and DBA utopia? So what is that utopia? We want to get out of those dark days of please may I have another, right? So what's in that for developers? Velocity, right? I can do things faster. I get changes that look roughly the way I want. Or when I'm doing something that a DBA doesn't think is the best thing to do, I get feedback from the DBAs, and I get education about why what I want to do may not be optimal, and I get to participate in that process. What does the DBA get out of it? Well, the DBA gets something very important out of it. One, they get out of a lot of drudgery of spending your entire life writing DDL files for a potentially infinitely large number of developers. You make it the developer's problem. Hey, you go pick up that template and write the 95th column add that needs to be done to this database. I don't want to do it. What it does for the company and the DBAs is it frees them up to do the things that they uniquely are qualified to do and study more than other people. Things like, let's actually look at my actual production performance. Do I need to do some optimizations? What query plans is my database engine creating for me? And can I change things about my database to make them better? We let them be involved in more high leverage opportunities than just spitting out, taking in requests from people, saying no, and delivering whatever they want. So that gets us pretty much all the way there. But let's talk about what that end state looks like. And we're going to talk about some patterns for that. Well, patterns and anti-patterns. So before we get into that, there's one pattern that I think overrides all of this. And I said I was going to be provocative. This is probably the first really provocative thing I'm going to say other than insulting DBAs, which is that your data has a life of its own. Your data lives longer than any version of your application. We'd like to think that's not true. Like you change your app, you change your database. That's not really true. Like, and if you want to test that, delete the data in your database, right? Like you'll learn pretty quickly that your app doesn't matter if there's no data in your database. So data is more important than you think it is. And so your persistence, where you're storing things, should be treated on a longer time scale than your application. Why? You could rewrite your application completely, right? It could be in Java today. You could rewrite it in Python. You could take PHP and move it to Go or Node.js. That doesn't matter. You might have a new application that needs to talk to the same database that does something completely different. You may have a customer-facing part of your application, and now you may want an internal dashboard for performance metrics or sales uptick or whatever it is. So applications can be replaced, but your data is forever, and there may be more uses of it than what you originally considered. So let's dig into the patterns. So the first pattern we're going to cover is version control. You should use version control for your database migrations. What do we want out of that version control? Well, there are a few things that are actually important in it, and one thing that we typically think about for version control systems that's less important for a lot of your schema migrations. So we want a centrally accessible repository for all of our changes. That lets all of our developers participate, and it gives a central gating place for DBAs and team leads and architects to be able to see what kinds of changes are being proposed or try to be put into the database schema. We want an audit trail. We want to know what changes were added when. When did somebody ask for this change to be made? What's the sequence of changes that we have asked for to be done? And we want the collaboration tools that a version control system provides us. First, its own that you can share, but also some things that are added on that we'll talk about a little bit later. The less important thing, surprisingly enough, is versioning of individual files. We care about that up until the day that a schema migration gets applied in production. The second you send it up to production, you shouldn't be editing that schema change file anymore, right? Like, that doesn't make sense. We already added that table. You can't re-add it. You can't resend it again. It gets added once. You need to change it. That's a new migration. But any edit to a shipped migration file, probably a bad smell test. So what's the next thing we got? This category of things called migration tools or schema migration tools. I'm sorry, so when we talk about schema migration, I mean the current state of my database, the tables and column definition, indexes, foreign keys, and all that looks like this today. And a schema migration says I want to go from here to some new state. That's separate from another database migration topic, which is like I'm running in this database over here that's maybe in a data center. I want to move it to a cloud, or I want to go from Oracle to SQL Server to Postgres or whatever. We care more about within one database. It looks like this today. I have some new features, new use cases I want to add, and I want to change the structure of my database. So what do we need? So we want ordering between the blocks of our schema change. So we want a migration tool that will, say, be able to pick up a file of SQL commands and run it. And we hope that it runs the SQL in the order that it exists in the file, right? Like, let's hope we can at least count on that. The next thing we want is we want it to define that when it has a set of files, it can figure out what order those files should be in. So I can determine that, D comes out, runs after C, runs after B, runs after A, right? Like I know what they're going to run. They're not going to get run in arbitrary order, so that a later migration that has a view that it's adding that depends on a table won't run until after the migration that adds that table. Next thing you want out of your tool is it needs to be able to keep track of, okay, well, what migration am I up to today? Here's a database. What state is it in? I'm here. And so it can figure out, hey, here's all my sequence of migrations over here. Here's a bunch of files. Here's my database, and it says I'm right here. So I need to pick up every migration after that and run that. That's what you want your tool to do. Next thing you want it to do is, ideally, when it's got multiple files to run, to say, each individual file, all of the changes that I need to make in that, ideally, all succeed or all fail as a unit. So when I run a file of a set of changes to my database, all those changes inside a transaction run or don't run. Ideally, if you can get away with it, it would be awesome if that tool could also say, when I have multiple migrations to run, I want to take every single outstanding migration, and they all either succeed or fail. I know that when I run a set of outstanding migrations, I either did nothing or I did everything. Not all tools, not all database engines support that. That's fine. You at least want it to make sure that when you have multiple sets of changes to run, that an entire file either succeeds or fails as a unit. Next thing we want to have is an audit log. I want to know what changes got applied to this particular database, when, by whom, did it work or fail, and ideally, what do we think the contents of the file that were run actually are? And that can be as simple as take the contents of your file, store the checksum of it, so you can go back later and say, okay, we think this migration ran. What's the checksum of the file? Does it match what my database thinks was applied to itself? Best way to do that is what I call sidecar tables. So you have the artifact in your schema, your tables, your columns, your definitions, your stored procedures, your views. It's awesome if your migration tool will put off on the side its own tables to say every time it applies, let's say, a file of migrations and that succeeds or fails as a unit, it writes a row that said, I tried to run this file at this date and time. Here's what happened to succeed or fail, and who did it. So once you have that, the next thing to talk about is how do we define an ordering of my migrations? Or what type of migrations we have. So we want to have version migrations. Hey, how do we define that sequence? So we have a lot of ways to keep track of version numbers. I gave an example here of semantic versioning or semver. I don't think semver is necessarily the right way to do database migrations. What does a patch to your database schema mean? I'm not sure really what that means. I'd recommend picking simpler versioning, whether it's just a constantly incrementing integer, 1, 2, 3, 4, 5, 6, or whether you use date and time, year, month, day, hour, minute, in that order. But when you do that, file systems are really good at giving you a list of files in lexical ordering, right? They can give you them alphabetically sorted. And so it would be awesome if we had a tool that would use convention over configuration. We like that in Devops, right? And says, I'm going to take a list of files, and I'm going to sort them in order, and now I know what order everything's going to run in. And now I can figure out what point I'm up to, and I got my list of files to run. So this is a weak pattern of something that I like to see in a tool. I will be honest, very few tools do this. The ones that do, I think it's wonderful. If you are looking at a tool and it doesn't do this, it's easy enough to build this on your own. I just feel like we have lots of things that know how to run SQL files and keep track of whether and when they've run or not. I'd rather let that tool do it than recreate it myself. But this is the idea of a repeating migration. So what does a repeating migration mean? And by the way, until I started researching current tools, I actually wasn't aware that it was called a repeatable migration. And that name still sounds weird to me. But the idea is like, if I have stored procedures or views in my database, I might need to rerun those anytime I change a table structure. Or my stored procedures, I might change the in or out parameter signature or change what columns get returned. Well, I can run that as many times as I want until the next time it changes. The version control system you're using, Git, Subversion, whatever it is, Team Case or Clear Case, whatever it is, all that stuff is plenty good enough for keeping track of the versions of your stored procedures. You don't actually need to ship it up in a version migration, because then instead of having one file that tracks all the changes of how did I change the stored procedure or view over time, I've got umpty-9 version files that I have to go back and check what the history is. So use your version control system for it. Run them repeatedly. Awesome bonus feature is if the tool's smart enough to figure out, hey, this file didn't change. I don't need to run it this time because nothing's actually different about the entire contents of this file. One important feature on top of that then is in your version control system, you do want to use release tags so that you can pin particular versions of your repeatable migrations to what database migrations had to have run by this point for them to be valid. But let your version control system do that. So that kind of covers features we want in a migration tool. Let's talk a little bit about acceptance flow. How do we make processes in Devops for migration changes to get into our system and get applied to a database? So one of the features you want to bring DBAs and developers together is you want to have a process where if a developer can write a migration, there's an opportunity for more senior engineers, team leads, architects, and so forth, and your DBAs to review the changes that are being proposed based on their experience with the database engine for things like what is the logical design? Are you making sense of this? Are there physical design characteristics of your database you should be taking advantage of? Does the logical design work well in the physical way you're going to build it into your database? And then a big one, which we'll talk about a bit more, which is what are the deploy time performance impacts of this? When this migration goes to run, is it going to complete before the heat death of the universe or not, right? So let's talk a little bit about what that flow looks like. I'm going to mention some tools and things that you can put together to build a workflow. So you want a set of workflow and controls about how things get into your repository. And for the purposes of this demonstration and for talk and the flows I want to talk about, I'm going to use GitHub as the assumption. I understand not everybody's using it. But in Git specifically, all your migrations should be submitted by a feature branch or pull request. Developer wants to make a change, they create a feature branch, make a migration with their changes, submit it as a pull request. That kicks off the opportunity for DBAs, architects, team leads to do a code review. There are all kinds of tools you can use. GitHub Issues if you're a GitHub user, the equivalent in GitLab, Garrett if you want to. There are lots of code review tools. Pick one, use it to go through the process of approving changes from the developer for sanity by DBAs and leads getting into your system. I'm going to make another provocative suggestion, and I don't hold this one strongly, but consider having the migrations in their own separate repository, not in your main application code repository. There are a couple reasons. When your databases get large, you may have to run your database migrations in advance of shipping up your application code. I'll talk more about why that might be and some strategies for dealing with that, but you might get into that situation, so you might find it useful to separate your database migrations from your application code in their own repository. So let's talk about some of those migration strategy patterns. Okay, when you get into very large tables, lots of rows, very wide columns that take up a lot of space, your migration is going to take a long time to run, and you're going to have to figure out strategies to deal with it. And you say, well, you ain't going to need it, right? The Agile, you ain't going to need it. Don't build it until you get there. Well, yes, but no, because these are easy enough to start with once you know the patterns. So the first thing you want to do is you want to basically write your migrations in a way that supports a blue-green deploy. Your migrations, when they ship, should work perfectly with the existing version of your application, not the next version that needs those changes in place. So things like when you add a column to a table, default it, or actually allow it to be null. Don't require that it have a value so that all your procedures have to be changed before you can apply that change to the database. Adding columns with default is a very problematic thing that needs to be done when your tables get large. You add a default table, and very quickly your database engine says, well, I need to lock this whole table because I'm going to be doing tons of work to it. Nobody else can write to it. So now all updates to that table are locked out, and you're sitting there for a long time. You can bootstrap up through that process. Don't create a new column initially on a big table with a default value and not null. Allow it to be null, don't set the default. In the background, you can run batch jobs that will pick up and start setting same default values to that column for you. And then when that's done, then you go in and you apply the default not null constraint. And all of a sudden, new rows will have same values under the old version of your application code that doesn't know anything about this, but you haven't taken a performance impact. You're able to bootstrap up. Then when the new version of your application goes up with new stored procedures, anything you need, it will immediately be able to use that new column, and it will know how to set it to different values other than the default. So that's it for my patterns. Let's talk a little bit about some anti-patterns that I think exist in some of the tools. And I'd say this section of the talk is all provocative. I think there will probably be some controversy about all of them or some discussion. And also there's no clip art because I couldn't find anything that actually did it. So you're going to have to look at black text on white slides for a while. Sorry. So we talked about that migrations can start running long. So doing your migrations on app startup, to me, is a strong anti-pattern. The idea that, and I'm not going to pick on them. Lots of tools do this, but we'll use the case, let's say, of Rails and Active Record. Then a new version of your Rails app comes up, and it says, Active Record says my schema should look like this. The database says it doesn't. I'm going to make a bunch of changes. I'm not picking on it. There are tons of tools I've seen in all kinds of languages. Django will do this for you in the Python world. A lot of the Java tools will do this for you. So I'm not picking on them. But when that happens, you have a bunch of developers. You may have project managers. You may have business executives sitting on your bridge line while this update is running, potentially. Now that you have that, you have a problem. You don't know how long those migrations are going to take. And I guarantee you, no matter how long you think it's going to take in QA, even if you had a full copy of your production database, what you can never simulate is the transaction mix and volume and locking behavior of your production workloads. Can't be simulated. I won't say it can't be simulated. I don't think anybody has successfully simulated it yet. I was talking to somebody who said, Facebook looked at doing this, and they had trouble trying to simulate that. So you're going to get unpredictable run times, and if you're waiting for your app to start up, you got a bunch of people waiting for it to happen. You don't know when it's going to be done. You don't know what's going to happen if you decide, well, we can't wait for this anymore, and kill it. So separate the two things. Send your database migration separately. Send them an hour before. Send them a day before. But separate them. So this is a weak anti-pattern for me, that your tool language needs to be in the same thing as your application stack. The question is why? If you have a Python app, why does the migration tool have to be in Python, especially if you're not running it as part of your app startup? Does it really hurt you if you have a Go or Java-based tool for your Ruby on Rails application? I would argue it doesn't. I mean, unless you think you're going to be making changes and submitting pull requests on the migration tool itself, like it doesn't have features you need and you're going to be changing it, why does it have to be in the language? What value are you getting from it? So there are advantages to divorcing those things, that you can look at what are the features I actually need this tool to do, not what language is it written in. The one time that it might make sense to look at should I use that tool will be, do I have the runtime available? If you're a Python or a Node.js shop, picking a tool that's written in Ruby might not make the most sense, because now you have to worry about gem installs and bundler and making sure you have the right versions. Or if you pick a Java tool and you don't have the JVM in your stack, now you got to drag that whole install along. So that's the one place you might want to think about it, but don't make it a primary consideration. Custom DSLs, doing something other than writing SQL. You don't want to get too abstract. I think the biggest argument for that is your DBAs, the people who know most about your database, they're going to be most comfortable with the native schema language or program, manipulation language for that database. Let's make it easy for them. Let's not get too far afield from that. The one counter to that is, it would be nice if there was a DSL available, something that might let us do like, hey, I need to add a whole bunch of tables in bulk. Let me just build up a data structure and automatically run it. If you find a tool that supports both a DSL but also lets you just use SQL, that might be a good thing for you. So prefer but don't require that you can use whatever the native format is. Let's call it SQL. Another anti-pattern for me, automatic generation. The idea to say I have some tool that will look at the state of one database, let's call it my staging database, and look at the state of my developer database and generate a set of differences for me, and hey, there's my migration, and let's just apply that. So that's great. It'll tell you what's different about them. What it doesn't tell you is why. Maybe I was doing some experimental work in my database and I forgot to take some of the things out that I put in, and I don't need them anymore. They're leftover. They're not doing anything. We don't want to run into that problem. We want to be conscientious about why things are going into our database. So you actually can use that tool, but it shouldn't be past the developer level. And kind of the pattern I would recommend would be, a developer can do that, but before you start making a set of changes, back up your database. Make a checkpoint of it. Do your work. If you want to use a GUI, some admin console to do it, go ahead, do your work. Get to your final state, the thing you're happy with. Run your diff tool, get that difference, but now stop. take it off to the side, turn it into a migration file. Be very explicit about, here's the stuff I know I need to run. Put that in and run it through your migration tool and test it locally by going back to that checkpoint of your database, loading it back up, and now running through your migration. So finally, my last anti-pattern, down migrations. Have you ever fat-fingered a number when you're typing something on the keyboard? What if you do that when you're saying, I want to go down 4 migrations, and you actually fat finger a 5? Well, now you got a problem. If the 5th back migration added a new table or a new column, when that's done, if you didn't notice it, you just corrupted your database. Now you have a problem. You aren't actually doing an update. You aren't actually doing a reversion. Now you're into disaster recovery. That's not a good place to be, so don't do that. So why do people think we want down migrations? The best example I've heard is because I'm doing a bunch of up migrations and we died partway through. Well, I hope during the patterns that we talked about, we covered the idea that an entire file of migrations either succeeds or fails as a whole, and maybe all of your outstanding migrations succeed or fail as a whole. I think that covers the case of most of why I've heard we need down migrations. The other reason would be, hey, I actually shipped a bug. This isn't right. I need to go back to a prior state. I don't think that's actually the right place to be, because that leaves us with a case sort of like airplane autopilots, right? You're flying along, the plane's doing its thing. Pilots are not as situationally aware when the airplane goes, I don't know what to do anymore, you take over, and you lack context. And most airplane crashes happen that way. Down migrations, when you've made a mistake, they put you right back in that same situation. It failed, you don't know what happened, now you gotta go do some forensics, ideally, probably when you're down, not a good place to be. So, having said that, I'm gonna mention a couple of migration tools and go over, this is not a universe, these are not my final recommendations. There are lots of tools out there, go look for yourself. By call out SQL migrate, one reason it's written in Go, which means you have one executable. Doesn't matter what environment you're in, JVM, Ruby, Python, whatever, you have one executable, put it in, does what it needs. The only downside I really see to it is that it enables down migrations. You could just not use them and wrap the tool itself in a shell script that doesn't let you ask for down migrations. Alembic's in Python. It has a neat DSL, which is basically Python to let you do what you want. You can break out into SQL. It also supports down migrations. Its big limitation, and mind you, I've shipped products using Alembic. Its big downside is it does not keep track in the database of what changes have been applied. It only knows the last thing. The last one I'll mention is Flyway. Pretty much ticks all the notes. The only real downside to it is that if you're not in a JVM world, it's written in Java, so now you need to install the JVM alongside it. But there are many others out there. Do your research. With that, hopefully I've convinced you on some of the processes and tools. And hopefully I didn't rush too much and I've convinced you. Thank you, and I think I'm over, so I don't know if we have time for questions, but I'll be outside later.
All right.